Okay, so today's lesson is on inequalities, and we're going to use a few techniques, algebraic, graphic, and substitution to solve inequalities. It's really, really important because inequalities are very similar to equalities, except they have a bit of a twist, so we just need to make sure that we're right with it. So let's get straight into it. Now, a lot of questions when you get to the HSC won't ask you to put on a number line. I'm going to ask you to do that always, because with inequalities we can clearly see if we're right or wrong by putting it on a number line. So let's just solve this one. So let's go to algebra. So I'm going to plus 5, get rid of that. So that's going to be plus 5 there. I'm going to minus 6x from here, so that means I'll minus 6x there. So I'm left with, I think 2 minus 6 will give us minus 4x, and here we've got 8. Okay, now this is the twist that inequalities have, because now I have to divide both sides by minus 4, and because of dividing by a negative number, the same occurs if you times by a negative number. With this equality changes sign. So it's greater than or equal to 2, negative 2. Okay, so let's pop that on a number line. So let's pop that number line in, and I'll put, so negative 2 is there. So that's just minus 2. And so what we'll do is that x is, so that's x there. And so because it's greater than or equal to, we're going to put a circle above it and circle it in because it includes that. And because it's greater than, we're just going to put an arrow that way. So that's the solution of that. Now, we can go back to the original one and just test it. Test a value that's greater than. Let's test 0, okay? So I'm going to test 0 because 0 will be around here, which is greater than minus 2. So that will become 0. That will become 0. So we're left with minus 5 is less than or equal to 3. And it's true, isn't it? So that means that we're correct in our ascension, in our algebra there. Okay, it's not just something that happens. It's something that's true, so we can be confident. So if we do a substitution afterwards, we can easily see that we're right. Okay, this is an interesting one, this second one. We're almost going to have to do it like as we go. So the best way is just to get into it. So I want to get x by itself. So I'm looking at this bit in the middle here. So I want to get rid of everything that's not x. So I'm going to go minus 2 from here, which means I have to do that to the other side as well. All right, so if I minus 2 from there, then on the other side I have to, minus 2 there, so I have to minus 2 there, and I have to minus 2 there. So I've got 18, and then I've got minus 3x, and then I've got, this is 6, all right. Now what I'm going to do is to both sides I have to divide by minus 3. So I'm going to divide by minus 3, divide by minus 3, divide by minus 3. Okay. So I get x, and this will be minus 2, and this will be minus 6. But because I'm dividing by a negative number, the signs change. Okay. All right. So let's pop that on a line. Okay, we've got x, so we've got two numbers now, minus 6 and minus 2, all right. Now, x is greater than minus 6, but less than or equal to minus 2, so let's put a circle filled in there and an empty circle there, and that is simply because of this is it's not an equal to as well. And then all we have to do now is just connect these two dots because it means that. All right. So that's what it means on the number line. And once again, we can test the value. I'm not going to do it because of the video, but test the value, say -3, that's in between, that's in the region that was discussed, that's in the region here, and see if this first one still works, okay? All right, let's go to another example, okay? We're going to solve these inequalities. Now, the best way to do these ones is to actually draw them, okay? So to draw them like we know. But first we have to do a little bit of algebra. So what I'm going to do is I'm going to take the 4 away here and going to move it to that side. So I've got x squared minus 4 is greater than or equal to 0, okay? Oh, I can draw this and I can see here is difference of squares, okay? So let's do that. X minus 2, x plus 2 is greater than or equal to 0. Okay. Now I can quickly draw that. Okay. So let's draw that. So I'm going to go there, there, and it has intercepts at -2 and 2. It's a parabola. Also -4 from the original one. And it's a smiley face, okay? So let's do that. So we go boom. Oh, that's not very good. Okay, you get the point anyway. So the question asks, when is this greater than 0? Okay. When is this greater than 0? Okay. When is it greater than 0? Well, I can see that it's greater than 0 here and here because all this bit down here is less than 0. Okay, so if I write that down, greater than 0, and bottom of the line is less than. Okay, so now we can write an answer on a number line. Okay, so I'll write the proper answer and then we'll put them on a number line. Okay, so therefore x is less than, and because it's equal to here, or equal to -2, so I'm talking about this one, it's less than that, and it's not a region, so with two separate answers, x is greater than or equal to 2. Okay, so how does that look like on a number line? Well, I'm going to draw my number line up here. You do it more neatly than I do. And we've got two lines here, -2 and 2. And I'm going to do a full circle in, and this is what it looks like on a number line. And test your numbers. See if it works. Okay? All right. Let's get to the next example. So, yep, it's a quadratic once again. I'm going to do it really quickly because I don't want the video to go to too long. So it's just going to be x squared plus 7x plus 12 plus 12 is less than 0. So I've made it equal to 0. I'm going to play magic numbers with 12. And I want to get to 7, so I've got 3 and 4. So it's going to be x plus 3, x plus 4 is less than or equal to 12. Let's quickly draw this. It's going to have intercepts at -3 and, well, -4 and -3. Okay, it's a smiley face because that's positive. So let's quickly draw it. Boom. And boom. Now, when is this less than 0? Well, it's less than 0 down here. So we put the x first. So therefore x, and I'm going to write it in red. Therefore x is greater than -4, but less than -3. Okay, so let's put that on a number line. Let's put the information in. So -4, -3. It's going to be empty circles because there's no equal sign, and it's going to be this region in there. Okay, so the best way to do it is to draw your graph, and you can clearly see if it's before or after, above the x-axis or below the x-axis. All right, so I'm going to do one more example, which is inequalities, and that will be it. I'm not going to draw a number line because I feel the video is going too long, so let's just do it. So we're going to solve inequalities exactly the same as we did absolute values. So I'm going to do the positive one. So I go 9 minus 2x is less than 5. So then we've got minus 2x is less than negative 4. Therefore, x, the sign has to change because I'm dividing by a negative number, is 2. Also, we've got to go minus 9 minus 2x is less than 5, and we've got to solve that one. So that will be, if we ski jump this to that, minus 9 plus 2x is less than 5. So we've got 2x less than 14, x less than 7. All right, let's draw our number line. We have our two critical values, which is 2 and 7. Now, x is less than 7, so that's this way, and x is greater than 2, so that's that way. So we can say, and it has to be empty circles, that these two will be connected here. So our final answer will be, therefore, for x in the middle is going to be greater than 2. Let's write that better. Greater than 2, but less than 7, just like we had on our number line. All right, I'm going to get you guys to do that on your own, but that's the end of the lesson for the moment. So peace out.